and this one make for a complementary angle, right? And the two angles formed at each vertex are complementary, which we just said. So these are kind of little corollaries here, if you will. Little supporting facts to that theorem. Another theorem. Look at these theorems. The diagonals of a rhombus are perpendicular. So if I look at my two diagonals, they meet at what degree angle? 90-degree angle. Okay, good. So I can say that AC is perpendicular to what? BD. Okay, and each diagonal of a rhombus bisects a pair of opposite angles. So bisects a pair of opposite angles. Okay, so these opposite angles are bisected. So that tells us that this is congruent to this, this is congruent to this, and they're all four congruent to each other. But it also tells us the same thing about these, right? So I can say that AC, let me do that in green, because that's what we said they were. AC bisects angle, AC bisects angle DAB and BCD, and BD bisects, so BD bisects ADC, angle ADC, and angle CBA. The diagonals of a rhombus form four right triangles. Yeah, that makes sense, right? So there's a right triangle. There's a right triangle. I see it. And the two angles at each vertex are congruent. We've already shown those. So this is kind of what I was talking about with the little chart. So if I look at diagonals of parallelograms, so I'm going to check off which of these properties pertains to each of these: rhombus, rectangle, and square. And remember, the square has the properties of the rhombus and the rectangle. So the diagonals are perpendicular. And, right, because remember the rhombus passes down the properties to the square. Okay, diagonals bisect each other. All of them. And even a parallelogram, right? What about the diagonals are congruent? Diagonals are congruent. Rectangle. And? Because remember the rectangle passes down its properties to the square. And what about each diagonal bisects a pair of opposite angles? So angle bisector. It is an angle bisector. Rhombus and square, yes. Good. So again, these properties were for the rhombus. These properties, this was for a rectangle. All right, let's look at some examples. Let's play with these properties. So you have been given a rhombus. So for our first example, you have been given a rhombus. RHOM is a rhombus. What do we know? What can you tell me? What do you want to find first? B? Okay. We know B is 4 degrees. How? Diagonals bisect each other, right? And therefore, these two pieces are congruent, right? What else? Maybe using the same fact? A is 3. A is 3. And C is 5. How do you know that?
Multiplying 3 and 4 by themselves gets 25, and dividing that by 5 we get 5.
What theorem are you using?
Pythagorean Theorem.
Pythagorean theorem, because what type of triangle are these?
Right.
Right triangles. So remember, this is the hypotenuse. So it is a special right triangle. It's a 3, 4, 5 triangle. There's a few of those that you'll commit to memory because you see them so often. So if I use the Pythagorean theorem, which says the length of one side squared plus the length of another side squared equals the length of the hypotenuse squared. So I have A was 3 squared, B was 4 squared, so that equals 25 squared. Oops, sorry. I gave you the answer instead, 25. So C equals 5, right? Okay, look at the next example. The next example, we have a rectangle. So let's look at what we know about the rectangle. We are looking for the length of WE. And how do you know that?
Because the diagonals bisect, that means WA is 10.
Beautiful. Excellent. Excellent. Okay, let's look at the next example. Oh, wait, I think we're on number 3. We have what type of shape? It is a rhombus, okay? And so what do we know about the rhombus? It's depicted in the picture. Well, it doesn't show us that, but we do know that if it's a rhombus. You are absolutely correct. All the sides are congruent, okay? And this is a right these are little right triangles. So what can you tell me? Do we know anything?
Why is the line bisects the angle?
Okay, I have an angle bisector. I agree with you 100%. So due to that fact, what value do we know?
Y is 35.
Okay, Y is 35. But why do we know that Y is 35? Opposite interior angles. These are these parallel?
You're wrong if you have anything to do.
Yes. Yes.
What is X?
Okay, how do you know that?
Because there's a line
Ooh, that's beautiful. Mm-hmm. Oops, sorry, 55 degrees. So again, we know this is 90. We know this is what? If you're going this route. Well, actually, we don't have to go that route. We can use the fact that this is congruent to this, since this diagonal is an angle bisector. And then, like you said, 35 plus 90, subtract that from 180, the sum of the three interior angles, I do have that z equals 55 degrees. And x is 55 degrees. Okay, let's look at the next example. We have a square, SQRE, and I want to know what x is. What do I know about these little triangles? Okay, they are isosceles, but more particularly, they're what type of isosceles triangles? They're right isosceles triangles. Mm-hmm. Yes. It's another way to do it. Absolutely. I know this whole thing is 90 degrees. This isn't, the diagonal's an angle bisector, so each of these have to be 45 degrees. Yes. Another special triangle, 45, 45, 90 triangles, right? Okay, let's look at the next example. I have a rectangle and I want to know what x is. What can you tell me? All the angles are right angles. Mm-hmm. Okay. Excellent. 62 degrees, yes. And again, we could do it a couple of different ways, right? We could subtract 28 from 90 to get this, which would be congruent to this. Also, would be another way to do it. Okay, another theorem. Now this one, we're going to spend more time on a little bit later, but let's see what it is saying. So I have the following theorem. The midpoint of the hypotenuse of a right triangle is equidistant from the three vertices. Okay, so let's go ahead and look at the right triangle. So they are talking about this right triangle that has this right angle. So this is the triangle that I'm looking at. I'm looking at the midpoint of the hypotenuse. So this is the hypotenuse of the right triangle. This is the midpoint of the hypotenuse, which I'm going to just label it M just to prove a point. A midpoint. Okay, so what this is saying is that I have a right triangle, I have a hypotenuse, I have determined the midpoint of the hypotenuse. It is equidistant. That midpoint is equidistant from the three vertices. These are my three vertices. So it's saying that from the midpoint to C is one length, which is equidistant. So this is congruent to this length from the midpoint to A, which is congruent. Oops, sorry, not there. Here. Do you see these three line segments that are all congruent? There are the line segments that are kind of coming out with one endpoint being the midpoint. So from the midpoint to each vertex, I have congruent segments.
You can draw a circle.
You can inscribe this rectangle, yes. Okay, oops, this is spelled incorrectly. Theorem. Okay, let's look at another theorem. If an angle of a parallelogram, so that's the symbol for the parallelogram, is a right angle, then the parallelogram is a right angle. And we know that because the opposite pairs are parallel. And this would be like a little transversal passing through that two parallel lines. This would be a transversal passing through these two parallel lines. So we could show that these are all right angles. Yes? Okay, let's look at another one. If the diagonals of a parallelogram are congruent, so let's draw the diagonals. So if those are congruent, then the parallelogram is a rectangle. Makes sense. So these have to do with becoming a rectangle from a parallelogram. Two more theorems. While these two demonstrate how to become a rectangle from a parallelogram, the last two are going to talk about how to become a rhombus from a parallelogram. Okay, first theorem. So here's our little rhombus. If two consecutive sides of a parallelogram are congruent, so two consecutive sides are congruent, then the parallelogram is a rhombus. So I need two consecutive sides. The other theorem says, if I have the fact that the diagonals of a parallelogram are perpendicular, there are my diagonals, and they're perpendicular, then the parallelogram is a rhombus. So again, I only need, and I should state that, you only need one of these to prove that it's a rhombus. You don't need both of them. We do need, in fact, more properties to prove you are square. But we won't talk about those today. So again, big umbrella parallelogram passes down properties to the rectangle and the square and the rhombus. And then the rectangle and the rhombus pass down their properties to the little square. Any questions on any of these theorems? No? Okay, so you have bookwork, right, and a worksheet. Everything is in there. If you don't have your book, I did go ahead and print out the problems from the book in case you didn't bring it. So if you would like one of those, you're welcome to come get it. It's yours. But you are filling out the homework page and the worksheet and submitting that as a single PDF in Canvas. I've noticed some of you have started correcting. Yay for you. If you haven't started correcting your homework, self-checks, be sure. Oh my gosh. Oh my gosh, let's get on those because
I did it the other day though, so I'm up to date so far.
Okay, fair enough. I also have